So we're going to continue and we're going to talk about scatter plots. So scatter plots are basically where I have a data value that has an X and a Y and I just plot it on a graph. As you can see right here, I have a data value here, I have one here, and I have one here. And all I'm doing is I'm plotting my X and my Y variables. So a scatter plot shows the direction of the relationship between the variables. Hopefully a clear direction is going to happen. Sometimes it doesn't, but for what you're going to do in this course, it will. So high values of one variable occur with high values of another variable, or low values of one variable occur with low values of another one. So that's what I'm saying is like if I have high attendance versus high test scores, or on the same foot, I have low attendance and I have low test scores. Or you can have high values for one variable with low values of another. So you just need to look for those kind of things and think about when you're looking at the data. So you can determine the strength of the relationship by looking at a scatter plot and seeing how close the points are to a line. And there can be power functions, there can be exponentials, and some kind of other function. Just know in this class, we're going to focus on lines. But if you're going to go on and do psychology or something with statistics, you might see different functions. So for a linear relationship, there's an exception. Consider a scatter plot where all the points fit on a line, and that's called the perfect fit. A horizontal line would in fact show no relationship. All right. So when you look at a scatter plot, you're going to want to know the overall trend. And here we're going to look at some. So if you see in these, I have some data in there. Now this one, I'm seeing that all the points are kind of lining up, one behind the other. But when I look over here at B, they all look pretty good except for this point out here. We're going to talk about outliers and influential points later in this, but just make note of that out there because if I'm going to try to make a line that fits this, my line might not be good because of this one data point out there. Here is a negative linear pattern. You can see where it's going down. And here's another one where it's kind of going down, but it's kind of weak because all the dots are scattered. All right, this one right here is exponential. Think about bacteria rate. When you start with 1 and then they start to expand and expand, they're going to go up exponentially. Now this one over here, there's no pattern. As you can see, they're all scattered, and I don't even think I could make a line to get anywhere where I could harness that to make predictions on these since they're all over the place. Okay, so now we're going to focus from going to these scatter plots to a linear regression. So when you saw the ones where it was a strong fit, you could almost imagine a line that got most of that data. So now what we're going to do is we don't even have to do this by hand. We put the data either into the calculator or into a website. I actually think the website's a little bit easier. And there's a lot of math and equations that go on behind the scene, but it gives me the line called a linear regression. And based on that linear regression line, I can make predictions. So rarely does all the data fit in a straight line. So again, I've got to make these rough predictions. So we're going to call this the line of best fit or the least squares line. And you might even hear it called the regression line.